A lot of cases we see this kind of diagram with arrows which indicate a desired air movement. You now have uh, knowledge to determine if this looks correct or not. Is this correct to you? In reality, it's not really correct. Based on the opening size, the neutral plane will happen somewhere above the middle of the building. Any opening that is above the neutral plane will have the air going out. And the diagram that we just saw before was not correct because it wasn't considering the location of the neutral plane. And this area will have a negative impact in terms of airflow because it will have a backflow while we want the fresher air coming in to all of the spaces uh, as we intended. How can we control that? We can have several architectural methods to control this neutral plane. First method on the option 1 is to raise the height of the solar chimney. So by raising the upper portion of the atrium higher than the upper portion of the rest of the building, we can move up a neutral plane a certain amount. We now are left with just a one floor that has the backflow. And second option is to control the opening size. If we make the opening size of the uppermost opening larger, the neutral plane goes up, but we still see a portion of the building that has the backflow. And third option that we can use is to literally make the solar chimney with a higher temperature. And this can happen by receiving the solar radiation and trapping its temperature at the top portion. And because of the uppermost area is hotter, naturally neutral plane will move up. If all of this doesn't work, then we can utilize a little bit of fan, which will naturally move up the neutral plane. And now we have every floor where the fresh air come in. When all of this doesn't work and you don't want to use any fan, there is an option to separate certain floor that's not working correctly to have its own set of buoyancy effect. For this first option, since neutral plane is happening at this location, we are separating this upper room and we are relying on its own buoyancy effect for it to be naturally ventilated. Or we can just air condition this room, then we still have properly working buoyancy driven natural ventilation for the rest of the building. We can also divide the building up into one large building and one small building by providing this separation. By doing this, we can easily achieve the neutral plane that is higher above the occupied area for this larger or lower building, and we can design a neutral plane that is higher than occupiable space for this smaller building. Since it is very difficult to achieve and design this natural ventilation, you have to be very careful on making decision to utilize natural ventilation. And again, when you draw a diagram of natural ventilation, you cannot just draw random arrows. Instead, you have to think about its air movement that is based on the actual physics of the air movement that we discussed. And also, remember the limitation on the outer factors, such as um, noise, precipitation, and pollen, and outside pollution, as well as the temperature. You might, depends on where you are, natural ventilation might not be feasible or applicable to your design. And let's look at the successful example of these wind-driven or buoyancy-driven ventilation works. First is the Commerzbank in Frankfurt, designed by Foster Partners. They are providing large atrium inside this triangular building, and they are, instead of providing one large atrium from bottom to top, they are separating the atrium to evenly provide a buoyancy effect for all the floors. It's a combination of wind-driven and buoyancy-driven ventilation, which creates negative pressure inside this atrium where you want the exhaust windows are located. In case of Manitoba Hydro Place in Winnipeg, the architect is providing a vertical stack of atrium that is preheating or pre-cooling the outside air before going into the actual working spaces. And image on the left is the example of that atrium that is stacked in total of 3. And it is also utilizing the solar chimney. It is made out of glass, continuously being heated by solar radiation in order for neutral plane to go up higher, and also it has created to be taller than the other building. The last building that we will look for a successful example and our inspiration is Qibao Control Center in New Caledonia. This is designed by Renzo Piano. The architect has designed this geometry to maximize its reaction to the wind, and it has developed its design further to be operable for many different scenarios.